Good morning students. Today we are going to talk about effect of catalyst on rate of reaction. Now what is a catalyst? A catalyst is a substance which increases the rate of a reaction without itself undergoing any permanent chemical change. Which means that it may participate in the chemical reaction, but by the end of the reaction it is regenerated back in its original form, that is in the same composition, same amount. In other words, a catalyst is one which provides an alternate pathway or mechanism of lower activation energy, thus lowering the potential energy barrier to form activated complex readily. Which means that what exactly is the work of a catalyst? It is going to provide an alternate pathway or an alternate mechanism for the same reaction, and this alternate pathway or reaction mechanism will be having a lower activation energy requirement as compared to when the reaction was carried out in the absence of a catalyst. And thus what will happen due to this, it will lower the potential energy barrier to form activated complex. And from our previous class discussion we have seen that temperature dependence of rate of reaction can be explained by Arrhenius equation, and in Arrhenius equation we had learnt about the term activation energy, and from there we already are aware of the fact that activation energy is a characteristic of any reaction. Higher is its value, slower will be the rate of reaction, and lower is the value of activation energy, higher will be the rate of reaction. Thus what is the role of catalyst when it is increasing the rate of a reaction? Actually it is lowering the activation energy requirement of that reaction. One example has been quoted here. Manganese dioxide is a catalyst which catalyzes the thermal decomposition of potassium chlorate, giving products potassium chloride and oxygen gas. Now in the absence of this catalyst, this reaction goes slow, but in the presence of this catalyst the rate of reaction is increased manifold. Now this can be understood with the help of this graph also. As you can see, a graph has been plotted between potential energy and reaction coordinate. Potential energy is taken on the y-axis and reaction coordinate on the x-axis. Reaction coordinate, as already explained in my previous class, it simply means the energy pathway which is followed by the reactants in order to change into the products. So here you can see there are two curves, one which is shown by bold line and the other one which is shown by dotted line. On one side reactants and on the other side products is indicated. Now where the reactants are written, at that point the potential energy or the energy which is represented by that particular point is actually depicting the average kinetic energy of the reactants, which the molecules of reactants possess as an average. The peak of the curves represents the threshold energy, which is the energy required for the reactants to change into products. But since most of the reactants are not having energy equal to threshold energy, then naturally we need to supply them that energy, and that energy is supplied in the form of activation energy. So the difference between threshold energy and average energy of reactants is the activation energy. Now the curve which is drawn with bold lines, that is the one which is followed by the reactants when no catalyst is used, whereas the one which is shown by dotted lines, that indicates the curve or the path, energy path, that is followed by reactants when a catalyst is used. And in both the cases the requirement of energy of activation is shown alongside. So as you can compare and see for yourself, the energy of activation required without catalyst is greater than the energy of activation required when a catalyst is used. And naturally the path, the energy path that the reactant is following in the presence of catalyst, that is also slightly different. It is a lower energy barrier path as compared to when no catalyst was used. So that is the main function of a catalyst, to reduce the activation energy of a chemical reaction, and that is how it increases the rate of reaction. How it increases? Now because the energy requirement is less, so naturally more number of reactant molecules are able to cross that energy barrier and change into products. Initially that was not so. Why? Because the energy barrier was high. Now there are certain characteristics of catalysts which you should remember. First thing is that when a catalyst is used in a chemical reaction in order to increase its rate, then that catalyst is not required in very large amount. Why so? I hope you already know. It is because the catalyst is not permanently utilized during a reaction. Temporarily it may participate, but by the end of the reaction it is regenerated back in its original composition and amount. So naturally it can be reused again and again. Therefore even a small amount of catalyst can catalyze a large amount of reactants. So that is the first characteristic. Then the second one says that it does not alter Gibbs energy change of a reaction. Delta G of a reaction remains unchanged. Then third, it catalyzes spontaneous reaction, but it does not catalyze non-spontaneous reaction. Means if reaction is non-spontaneous, then no catalyst can increase its rate of reaction. And fourth point is, it is also found that a catalyst does not change the equilibrium constant of a reaction, which means that the equilibrium state will not be disturbed. Only thing that will happen in the presence of a catalyst is that the equilibrium will be attained at a faster rate in less amount of time. And why it is so? Because a catalyst affects both forward as well as backward reaction. It will not only increase the rate of forward, it will also increase the rate of the backward reaction, and also to the same extent. And hence the equilibrium state will remain unchanged, and only thing that it is going to affect will be the attainment of equilibrium in a less amount of